We're catching up on some of this here on kind of a post-live stream. We've had our internet gremlins again this morning. We had it yesterday, but it was yesterday afternoon, and today they seem to be back in force. In order for all of this stuff to work, it all has to be on the same wireless network, and we have 5 here in this house and in the studio, and for whatever reason the most reliable one, which has always been up here for that network piece, now today for whatever reason keeps switching back to one that's downstairs, and none of this stuff is on it. So I'll be checking this periodically to make sure I'm still broadcasting, but it looks like now it's going to hold. I had to reset everything, and it's just Lord. The good news is that I did it in paradise. Oh, I know. That's where I wish I was right now, guys, and I wish I could take all of you with me, and we would just have it right here beside the falls here in Maui. This is actually a part of the island of Maui. And the reason that I chose the island of Maui is because that is going to be one of the things that we're going to be looking at today on some of the approach plates, the arrivals, the airport diagrams. And so this is part 2 of chapter 23, and we're going to pick this up here on the instrument approach plates, because before we can start with any of the stuff in the text, I believe it would be helpful for you guys to have a working knowledge of exactly what these plates actually mean. Back in the day, they actually used to be these hard kind of plate things that people used to use. They're pages, they're images, they're documents, and we still call them plates, nostalgic that we are. And so that's what we're going to be looking at. And so Mrs. Benton has handed out to you, and hopefully in the large format stuff, because you guys are going to be writing notes on these things. This is probably going to be just these plate pieces. My guess is it's going to be a 2-part piece here as well. And I just realized I forgot to set the timer. So you know, talk amongst yourselves here while I reset this. Boy, how do I do that? Well, I'm just going to start it, and hopefully I'll catch it here. So many things I forgot to. Yeah, anyway. So that's what we're going to be looking at today before we press on into the text here for these instrument approaches. Understand that we're going to be talking about things and introducing subjects that won't come into deeper forms of study until after this. So this, for some of this, it is a direct correlation to what is in the chapter. Some of it is going to be a peek at what's coming next. So I just wanted to let you guys know that. So that's kind of it. So to start things off, what I would like to do is I want you to pull up what we discussed here in the first part of this, which is an arrival. Now, the reason that I'm using these for Maui and the Hawaiian Islands is because they are different than what you guys have in your packages. But I want to show you these first on something different, so then you can ultimately then take this information and then use the corollary to the stuff that you have here, which is going to be for Colorado and New Mexico, but also for the corollary of the things that you have to study in your book, just so that it's different. A lot of the sim work that we do in the Hawaiian Islands, because of the performance algorithms of the airplanes, is that we can perform at sea level, but we still have terrain, as you'll see here with things, and we also have wind. So that's what we're going to be doing. So what I want you guys to do is to pull up the Camps 3 arrival. Camps 3 arrival. So I want you to pull that up and get ready to start scribbling some notes on that. So this is some imagery here of the Camps 3 arrival. Now, the first thing that I'm going to do is we're just going to give just kind of a brief overview of what this looks like here. So what you're seeing here is that you're seeing here. You can see in the upper right-hand corner, you can see Maui. So there's a VOR there at Maui, and so, you know, hopefully you would know that that's ground-based radio navigation, and so there has to be some ground underneath it for it to be ground-based navigation. So that's going to be there in Maui. You can see all of these lines kind of headed off there to the southwest with this. And then you can see here in the corners, you can see something here called Lanai. This is a VOR on the island of Lanai. This is going to be a VOR on Upolu Point, and that's going to be down in, oh, I forget the little island where this is down here. And showing these things here, these intersections called Harpo down here, Kiiki over here, and then Camps here. You will notice that from Camps, you have this straight line here, and this is what we would refer to as your inbound course, 024, your inbound course, to come in here and land in Maui, hopefully on runway 2. Okay, so we're going to come back to this, but I just wanted to show you that here just real quick. And then I want to go back here. Let me see if I can do this. Hold on, I kind of messed that up. Let me close that. I want this one. Is it Haiku? Yes. Okay, and here is the Haiku 1 arrival. So pull up now the Haiku 1 arrival. I love the names of these things. So the Haiku 1 arrival. Now, based on what you know about some of the lower altitude charts and knowing how to read these, you can see that somewhere here up north, presumably out somewhere in the Pacific Ocean, you've got flight level 200, which is 20,000 feet MSL. And then you can see these kind of these headings, these courses that come down here into these little figures here. And you can see Unadi and Because. I love the names of these things. Notice that all of these intersections here are all 5 letters. So you have APAC up here, Beta here, Because here, and these are GPS waypoints. This is RNAV, which is going to be GPS. So you can see these GPS lines all leading down here to this Lindy intersection, and then they kind of come southwest. And now do you notice something that looks familiar down here? So here's Harpo down here, and if you will recall, when we look here at Harpo, here is Harpo down here. This one on Camps 3 is identified by ground-based radio navigation. This one in Haiku 1 is by GPS, and GPS is going to be lat and lon. These are established by mathematics. So this is where we have established these. The only way that you can see these here on Haiku 1, these waypoints, is to have an updated, working, calibrated GPS receiver in your airplane. That's the only way for you to see these. So it's a little bit different than what you see here on the Camps 3, which is all ground-based, okay? So I wanted to show you the difference there between these, and we're going to come back to these. So don't worry about that. Now let me go see if I can go back to this. And no, dang it. Close tabs. No, cancel. Darn it. Hang on. That's what I want. And so those are the 2 there. And then I want to get to, oh, this one. Hang on, hang on. Now I want to pull up here. Let me minimize this. And now I want you guys to pull up. This is going to be, let me get to it here. I apologize. This is the ILS or localizer for runway 2 here at Kahului. Kahului, that is the big international airport in Maui. So this is the one that I want you guys to take a look at, because now we're going to start breaking things down. As we look at this pane here, we can see that we see the same type of things that we saw in that arrival. We see kind of why there is a corridor here, from here just kind of south and southwest of the island, kind of running here north-northeast. And the reason that we have this corridor is because we have terrain here on both sides of the island. Here, kind of in the southeast part of Maui, we have Haleakala, and that's over 10,000 feet. And it's impressive because you see that coming right out of the water. So it'll get your attention. So this is Haleakala, one of the big volcanoes up there. And if ever you guys get a chance, and some of you I know have, they're on Maui, seeing the top of the crater at Haleakala, it's glorious. And then over here, and I forget the name of this one here, kind of in the northwest part of the island. And here's another one here at almost 6,000 feet. So naturally, we don't want to hit that. You know, the principle of DHN, don't hit nothing. So this is why we see these courses. And if you'll remember from what you saw on the Camps 3, the arrival, is that you can see here is kind of an outline of this, but the Camps 3 arrival is to get you to Harpo, Keiki, and ultimately Camps, because it is Camps where everything really truly begins for you to begin your approach to runway 2 here on Maui. All right? So now, we're going to talk about how do we break down these approach plates and what is it that we want to use. I'm going to pull the pen on this here, see if I can draw on these things. I think I have this here. So with this, I'm going to pull this aside here just a little bit, and you'll notice that I have pulled this down about midway down in the approach chart. Oh, let's see, I've got to put it actually on that paper. It won't let me write in the margins. Stand by. Let me do this, and let me adjust the size here. Hopefully that'll do it here. There we go. Number 1, the very first thing that we do when we pull up an approach plate, we pull up the one that we think we have for where it is that we want to go, but the very first thing that we do is we check the date. Is this a good date for this chart? Is it current? That is the big thing that we have to check. If it's not a current approach plate, we can't use it. You cannot use this legally to fly this approach. Why? Because things change. And I'm going to show you graphically what I mean by that here in just a little bit. That is number 1. Nothing else matters if this is an expired approach plate. So, rule number 1. Is it current? That's the first thing we look at. Is this a current plate? Next, we're going to look here and make sure, number 2 here, is this where we actually want to go? This is the ILS or localizer for runway 2. Runway 2 at Kahului, which is the ICAO identifier here for Maui, okay? It can be a little confusing. So you have to make sure that that is the right airport and the right runway. Do you have any idea how many times that professional aviators out there at the pointy end of these great big airplanes land in the wrong city, wrong airport, wrong runway? It happens. It doesn't happen that often, but it still happens. So, as to not get confused about where you're going, we double check the upper right-hand corner of that plate to make sure we're going in the right spot. Okay. Now, after we know that we have the right runway, the right approach plate for the right airport, now we come over here and I'm writing over here, and you guys write along with me, because these are going, the reason that you have those, the paper out there today is for you to take notes on how to do this. So then we come over here to number 3 in the upper left-hand corner, and we're going to take a look at this box. You can see that on this line we have 3 boxes. So what information do we have here in these 3 boxes? We will read these boxes from left to right, okay? So when we look here at the top strip along this top, we can see that we have the localizer with DME for I-OGG. I will indicate the localizer for an ILS, an instrument landing system, that will give you not just left and right information about a localizer approach, but it will also give you vertical navigation that will give you what you need to not just hold your airplane on course left and right, but to hold your airplane on course on the correct slope so that you come in at the proper angle, and to avoid any obstacles as you're bringing your airplane in to land. And you can see that it gives you the frequency here of 110.1. You want to double check the fact that you have the correct frequency for the ILS. There are some, especially in congested areas where, like, for instance, Southern California, Lord, you got to make sure that you're on the correct frequency. The G1000, when you load an approach in the G1000, and we're going to get there, when you load an approach into the G1000, it will automatically put the correct frequency for that localizer, the ILS localizer, I-whatever the localizer happens to be. It's a 3-letter localizer. It will automatically load that into the standby box of your navigation window in the upper left-hand corner of your primary flight display. You have to flip it over to make it active. Okay, so you want to make sure that you know what that frequency is, because otherwise, if you don't have the correct frequency, you're not going to get the localizer stuff, you know, localizer or glide slope, so that you know how to fly this approach. Then you have your approach course. Well, Mr. R, if this thing is so smart and it's going to load all this stuff up here for me, isn't it going to give me the right approach course? Is it? In some cases it may, and in some cases it may not. So you want to make sure that everything jives with what you're thinking. If you're going to land on runway 2, you better have some kind of an approach course that's going to give you a 0-2 something to get you lined up with that runway. And so you want to make sure that your approach course here on 024 is going to be a course that will get you to that airport lined up correctly. So that's what that means. And when we look here at this approach course, we can see, yes, here we go. Here's our approach course of 024, okay? So that's going to head us up here roughly north-northeast to land on this runway. The next thing that we have here is we have our runway landing area. So we have approximately 7,000 feet of runway to work with to wrestle this puppy to the ground. In smaller aircraft, you may only need 1,000 feet. In great big aircraft, you may need more. Now, the great big aircraft that are coming in, remember, these people have flown over a lot of ocean to get there. So they're going to be coming in. The airplanes are going to be lighter because they've burned a lot of fuel to get there. And so putting that airplane down in 7,000 feet should be no issue at all. But what if you take off? Now you're taking off here from Maui, and you're heading to Asia, you're heading to the United States, the lower 48, heading to Australia. Let's say that you have a problem, and let's say that you need to come back and land. Well, now you got a whole bunch of fuel. What do you do with it? Well, environmentalists are not going to like this, but if you have a problem, you got to get rid of some of that fuel. Where do you get rid of it? Yeah, I know. You got to dump it. Dump it somewhere. I hate it. Everybody hates it, but we all like being alive. So that's kind of the deal. But if you come in heavy, you're going to have to come in a little faster, right? Remember how all of that stuff works in our performance tables? So when that happens, you're going to have to come in faster. You're going to be using a lot more runway. Now, things become a little bit more critical, and you've got to know how many feet that you have to work with, because you may have to use all of it. So then your touchdown zone elevation, TDZE, 54 feet MSL, airport elevation, 54 feet MSL. Okay, so this is where you look here on this top strip, on the top left-hand corner, the third thing that you look at on this thing to make sure that you have the right frequency, the course, and you are familiar with how much runway you have to work with and where you're going to set this bad boy down. Okay, then number 4. Now we're going to look at this strip. Let me kind of take this thing out of here so we can focus on this. Now we're going to look at this strip. Now then we can see on the T and E, here's your T and A rather, here's your homework. Look that up. Tell me what that means. You can see that DME or radar is required. They got to know where you are. For an in-op ALS, approach lighting system, increase the ILS Category E visibility to 3/4 of a statute mile, and the localizer categories CDE visibility to 1 3/8 miles, here statute miles. So what that means is that if for whatever reason the lights are out on your approach coming in, you have to be able to see better than you would if the approach lighting system was coming in. Okay, so you have to be able to read this. The next thing that you need to look at here is what kind of lights are we looking for? We're looking for Mauser. What is a Mauser? Well, you know where to find that information, right? You can find that at the front end of the legend section here of your chart supplement. So you know where to find all of that. Then, the biggie, the missed approach. Remember what I said before. To memorize anything on these approaches when you come in, the one thing that you want to know before you begin your letdown is what are you going to do when you go missed? Notice I didn't say if you go missed, when you go missed. So to execute the missed approach, you need to know right up here in the supercomputer what you're going to have to do when you go missed. Okay. So here you go. On your missed approach, you're going to fly straight out to 3,000 feet on the OGG VORTAC on the 023 degree radial to the crane intersection at 13 DME and hold. That's what you're going to do. So in essence, you're going to fly straight out to 3,000 feet and you're going to hold at approximately 13 miles north-northeast of the VOR. That is your missed approach instruction. When we get to the plan view here, I'll show you something else. That is what we call the published missed approach instructions. Okay? So that is going to be on that second line here, and the number 4 thing that you look at on that strip. Number 5, here's the next strip. Now then, you'll see a lot of information here on this strip having to do with numbers. You see these numbers here? These are frequencies. This is where we use the radio. Okay? And when you look at these here, you'll notice that from left to right, they list the frequencies that you are going to need, in most cases, in the order that you are going to need them. So the first thing you're going to need to know is you're going to need to know the ATIS, the Automated Terminal Information System or service. And that gives you, of course, your weather and the operational information that you have for that airport. that's the first thing you're going to do. You're going to want to pick up that information from as far away as you possibly can. There's a way to do it. What you do is you have 2 different comm radios in your airplanes in most cases. In some cases you have 3. And so you can have your first officer listening for those radios, or whoever the pilot not flying happens to be, listening here as far out as you can to get the ATIS information that you need as you come in. Or when you're flying by yourself, you'll hit your second radio, but your monitoring portion of the second radio, and you'll start to hear it as it comes in. It'll be staticky kind of at first, and then it'll start to come in as you get a little bit lower and as you get a little bit closer to the airport. And you record this information. You write that information down in the same way that we did it when we went through the weather services section here earlier a few weeks ago. And you write that ATIS information down. Upon initial contact advised, you have information Bravo. That's what it's going to be. So you'll have the ATIS that comes in there first. Then from the ATIS, you're going to talk to approach. And in this case, you're going to talk to somebody, probably Honolulu Control. If you're coming in from the north, the frequency you can expect is 120.2. If you're coming in from the south, you may expect to pick them up on 119.5. Do not be surprised if when you call them up and you let them know that you're there, Honolulu approach, United 232 Heavy, inbound landing, Bravo, is kind of what you would say based on this. United 22 Heavy, Bravo, radar contact, blah, blah, blah. Expect the ILS runway 2, you know, that type of thing. And then you repeat that back, and then you kind of know what you're doing. Now you're talking to and monitoring the approach as you come in, okay? So this is what you've got here. If you're coming in from the north, you have one frequency. If you're coming in from the south, you have another. Now, to the right of that, you can see these other frequencies here. What the heck are those? Those are military frequencies. Military uses a different band here on the radio scale for them to use. And so the military stuff, they can also use these, but they talk on a different frequency. And they have some other things on here too that they have in their aircraft mostly that they can use that a lot of us, you know, little guys don't. So keep that in mind. So that's going to be a military frequency that you see there. Okay, once you get close enough and you begin your approach, who's the next person that you're going to talk to? Well, how about if we talk to the tower? Because at some point we're going to need a clearance to land. And in this case, the tower, 118.7, that is going to be the control tower there at Maui. Okay? Next, after you land, they will switch you over to ground control. Ground control, then they will kind of direct all of the traffic. Once you have landed, you've pulled off the runway, you're safely cleared of the runway, you have pulled past the hold short lines, and you are now ready to taxi to the gate, taxi to the general aviation side, taxi to wherever it is that you're going to taxi. They're the ones that control that. 121.9er, 121.8, 121.7 are the normal ground frequency channels that are available to you at these airports. I have seen some other ones, but those are the most common. 121.9er, 121.8, 121.7 are the most common. Then from a clearance delivery standpoint is that this is going to be that thing to pick up your IFR flight plan, let's say on the way out, and you want to get your clearance for you to go somewhere else. And let's say that the tower is closed. Well, if the tower is closed at that time, the Unicom frequency is 122.905. Okay? So those are the lists of the frequencies there on that strip. Good so far? Okay. Next, we're going to take a look down here, and I'm going to kind of take some of this stuff out here just to kind of make it where it's easier for you guys to see. Next, what we're going to look at, and I'm going to shrink this slightly here, guys, so that we can see all of this. Hang on here. Let me get this where I can. Pardon me here while I'm kind of playing with this. Okay. Next, we come to this area. This area right here. This is what we refer to as the plan view. Remember what a plan view is. The plan view is a God's eye view. It's a top-down view of the area showing you what this approach is going to look like. And it also shows you a whole bunch of other stuff. So with this is going to be, and I took this off, that's 5. This is 6, okay? The plan view portion here for your approach plate. Now, the first thing that you notice here at the very outset is you see kind of this geographical top-down view of where it is that you're flying into. This type of a view here coming into Maui is somewhat foreign to people who are flatland flyers, because in most cases the geography that you see is going to be relatively flat, and it will kind of look like that, you know, where there's not a lot of the elevation contours that you see here in Maui or in the mountains. Okay, so just kind of know that this is looks a little different than it does at some, just because of the elevation. The other thing that you're going to notice here is that you have a lot of information on this thing. Now, there is no gospel way for you to take a look and to kind of brief what it is that you're wanting to brief, but I kind of like to work backwards from the airport. So if I take a look here at the airport and I know that that airport is those 2 lines right there, that is what I know that the airport is. How do I know that that's the airport and what that looks like? Because in a second I'm going to show you the overhead miniature diagram of what the airport actually looks like. Okay? So here I can see that I have a VOR that's out here past the end of the runway here. I also can see that I have one of the older NDB indicators here that I have here before you get to the runway. Okay, so that could be the inner marker here for my approach coming in. I see that that VOR, this is the OGG VOR, and that VOR is 115.1. I also see a little bit further up here to the left a confirmation of what my localizer is, which is 110.1 IOGG, which is what we discussed up here in this box. So those are going to be a confirmation of what it is that I'm going to need to come in. I know I need the localizer because that localizer is what I'm going to use to give me my vertical guidance and my horizontal guidance. But why do I want to dial in this information here in Maui? Why is it that I want to do that for the VOR? The reason I want that VOR in is because of this. This is because I am planning on going missed. So I'm going to have my number 1 nav set up here for this localizer. I'm going to have my number 2 nav set up, ready to go with the Maui VOR. Okay, so that's what I'm going to use. I'll have those 2 set up here in my navigation. So I want to know that I have those ready to roll as I am making my approach. Now, there are certain times that you turn certain things on and off, and we'll talk about that as we kind of get closer to it. So now I'm going to work my way out here toward where I want to begin my approach. And you can see here, as we talked about in the books, these IAFs, the initial approach fixes, and also you'll notice that the camps is not just an initial approach fix, but it can also be an intermediate fix, okay? Here at camps, because this is where I am actually going to begin my feeders. Remember what we talk about when we talk about those darker lines going in here to the feeders in here to begin your approaches? This is what we have. So we have those transitions that we saw in the arrivals of the Camps 3 arrival. And then from that transition, then we begin our feeders, which is what I'm showing you here with these red lines, and these dark black lines like that are the feeders that take us in here to Camps intersection to then begin our approach to the airport. Now, let's say, we talked about this terrain, and we know that, we always want to operate on the principle of DHN, don't hit nothing. Here's a way that can help us make sure that from an altitude standpoint, we won't hit anything, at least anything not moving. Here we have our minimum safe altitudes, the MSA. It's a 25-mile radius around the OGG VOR, which is right there, okay? And you'll see that in these quadrants, on these radials from this VOR, these different radials, is that you can see in this quadrant here, if you stay above 3,400 feet MSL, you're not going to hit anything. In this quadrant over here, if you're above 7,000 feet MSL, you're not going to hit anything. If you're above 11,300 feet in this quadrant over here, within 25 nautical miles of that VOR, you're not going to hit anything. Okay? So that is why these things are so important, because remember that story that I told you guys about being vectored the wrong direction when I was coming into Albuquerque from Santa Fe, and they had me making a left turn right into the Sandias. Well, I happened to know that was just wrong because I knew the area pretty well before I went in. But when you brief your approach plate, you want to know that when you're flying a particular direction, this way gives me some safety, this way may not. And so you want to have that in your head as you're flying into these things, again, just to exercise the principle of DHN, okay? Delta Hotel November. So that's where you get your minimum safe altitudes, okay? Now, in the upper left-hand corner of this is a little unusual here, because here we have two different insets. Number one, this is a plan view graphical illustration of the published MIST approach. So remember up here where it said to climb to 3,000 feet on the 023 degree radial of this VORTAC to the crane intersection, which is 13 DME, and hold, okay? Here, it actually shows you what that's going to look like. So here you are, you have flown out, well, it's not going to let me do that. Hang on. Here you are, you have flown out this direction on the 023 degree radial outbound, 13 nautical miles, and this is going to be that 13 DME. This is where you are going to begin your hold. And you have seen this racetrack pattern. Remember, my children, we have not discussed holds yet. Holds come in chapter 28. However, know that a hold, we have talked about them, holds are going to be these racetrack pattern ovals that you can ultimately fly, and what that does is that buys ATC time to get you back into the queue to fly another approach to come back here and land in the event that you're unable to land. So that's what these are. So these are these holding patterns, and it gives you the approximate headings. It gives you all of the information that you need to know to fly this holding pattern. We'll talk about the holding patterns in chapter 28, but just know that that's what that is and why it's there. It's kind of a time holder. I don't want to say it's like timeout, although it can kind of be timeout, because it's a place where ATC knows that if they need to move something off their chessboard here and put it somewhere over here where it's safe while they work out these other issues, then work you back in to fly the approach, this is where that they know they can do it. Now, what do you say that we're having some issues there at the airport? Now you've got 3 aircraft out here at the published MIST approach, stacked at various altitudes that they have. Well, guys, we've got too many airplanes out there. What else can we do? Well, how about the alternate hold? So here is the alternate MIST instructions. And the alternate MIST instructions are going to be flying you out here and basically taking you northeast of the island and, I'm sorry, northwest of the island on this particular radial of this VOR, and flying and put you in a holding pattern out here before they can bring you in. MKK, that I think that's Molokai. I think Molokai, and Molokai is off to the northwest of Maui. And so you have Molokai over here, VYI, I'm not sure, that's Valley Island there, but I think that's a little different. I'll have to check on that one here. But to find that plumb intersection, so here's what you want to make sure that you know before you begin your approach. You want to make sure that you know where that is. I'm sorry, not this. Crane, where this Crane intersection is, and you want to make sure that you know where that plumb intersection is. Now, here's something else. This particular hold here, this new published MIST, is relatively new, okay? Because it didn't used to be this way. And I'll show you that here in just a little bit. But these are the two published holds. You have your primary up here, and then your alternate MIST approach here, okay? Now, does that mean that those are the only two places where they may try to put you and, as they say, rack 'em and stack 'em? Not necessarily. They can give you a non-published hold instruction where they send you out on a different radial to a different distance at a different altitude. All right, everybody, we should be live here for part 3. We're going to pick this up where we left off in beautiful Maui, Hawaii. Back to the action. So, where we left off, we were talking about here, we were talking about, what this plan view piece means and our MIST approach. Now that we have our MIST stuff figured out, now let's start thinking about how we don't miss, okay? So if we look down here in this portion of our plan view and we look at our initial approach fixes that we have available to us that allow us to begin this approach. We have our transitions coming in, one here from Lanai. We have another transition coming in here. This is still coming in here off Lanai, off this transition here. And then we have our target, which is camps. Camps, this intersection is where we will ultimately begin the approach. So down in the bottom part, Harpo takes us here to come to camps. Keiki takes us from that intersection here to camps. So if we're coming in here from some of the other islands this direction, Keiki may be the most logical place for us to begin our approach. And that would be the initial portion, our initial approach fix that we would list whenever we are loading our approach on our G1000. It'll ask, where do you want to begin this approach? Well, if I'm coming in from the north, the northwest, I'm probably going to choose Keiki, unless there's some compelling reason for me not to. If I'm coming in from the south somewhere, let's say I'm coming in from the Big Island, then I'm going to probably use Harpo as my initial approach fix to begin my approach. Okay, so that's why those things are there. So we can see here that these intersections have been established by ground-based radio navigation, or VOR. They've got the little triangles there. So now, as we look at this, we see the initial approach fix at Keiki. We can see that this is from the Lanai VOR, and we see this kind of an image here. It's like a big D with a number in it. D standing for distance, the number standing for nautical miles. So what that means is that it's been 17 nautical miles from the Lanai VOR to get to that point, okay? And so that's kind of where we have, this information. And from over here, from Lanai, it's been 26.6, D standing for DME. That distance measuring equipment, or that distance from a particular point. In this case, it's from the VOR. Now, as we look here, I'll take these out. As we look here at this information into our feeder, we can see they want us here at 3,000 feet, okay? We're going to be flying a course roughly of 09 or 5, okay? And remember I said course, not a heading, because depending upon the wind, you may have that airplane pointed in several directions, but it's that course of roughly 09 or 5 to get you over here to camps. And the distance between Ka'iki here and camps is 4.4 nautical miles. So if you're traveling at a ground speed of 120 knots, you have just outside 2 minutes to get everything ready to go, okay? 2 minutes. If you're coming in here from Harpo, they want you at 3,000 feet. You're going to be flying a course roughly of 275 degrees, remember, not a heading, and it is 5.1 miles. Excuse me. And so at a ground speed of 120 knots through here, you have just over 2 minutes to get everything planned to set for your approach. Okay? So then you have to get to camps. Well, before you get there, you see these little things here that kind of cross. And you see these deals here, lead radials. So what you can do, remember I told you that you can set your VOR in one of your second navigation systems, and what you can do is you can set this up to give you notice when you're crossing this lead radial here and here as you're flying this direction or this direction. That gives you a heads up that here pretty darn quick, you are going to be making a turn coming in here to accept your final approach course. That's what it does, is it gives you some time to be able to make that work. The faster flying airplanes, it works a little bit better for them. Kind of the slow flyers, you're probably not going to start your turn until you're closer to this. Is normally where you're going to be because you're flying slower. But it gives you that information that you're going to be starting to make a turn here to intercept your final approach course, okay? And once you're set up here on your approach course, this is what you're going to be flying, an approach course of 0 to 4 degrees. And you're going to want to make sure that in your that on your system, whether it's your HSI or it doesn't matter if it's on a G1000 or just a regular HSI, that you're set for that approach course of 0 to 4. That's what you're going to dial in to make sure that that is your approach course. The G1000, if it's updated and everything on it is accurate and calibrated, it will give you the final approach course of 024, and they should match, but you want to check just to make sure. Okay? Now, before we start flying this final approach course, you'll also notice this out here like that. This is another area, another holding area. This is an area that has been established where they could ultimately put you to hold. Now, they may or they may not. It depends. They used to have you out here to hold, but right now they have sort of changed things, as I'll show you in a minute, where they kind of don't have you coming out there to hold. So it's going to be interesting to see what happens here. I sort of anticipate this hold to stay out here for a while longer, but you just never know. And it shows you here from this intersection at camps. This takes you then here on the IOG 17.7 miles, okay, that will take you to the localizer. Now you're going to notice that the localizer is going to be at the far end of the runway. So 17.7 is not going to be to the approach threshold, it's going to be to the far end of the runway, and you'll see that here in a second. You'll also see that on the 09 or 5 degree radial that from the Lanai VOR, it is a DME of 21.4. Why does it show those things out there? My gosh, Mr. R, we have a G1000. It does everything for us, including cook our breakfast and do our taxes. Well, some airplanes don't have G1000s, and they have some of the older style instruments, and you have to know where that intersection is, not just because this fancy television shows me where it is, But some people have to actually do the math. And with this, this is where it shows you the distance from that particular VOR on a particular radial. That's how the intersection is established, is with that information. Okay? So, understand that. Now then, we can see also here at HARPO, I'm going to use HARPO as an example again, is that we talked about the altitude they want you at, the course they want you to fly, the distance, but we see something here that says no PT, no procedure turn. In some cases, when you're flying to a particular intersection, they want you to fly a procedure turn that will get you turned the right direction to establish yourself on the inbound approach course. In this case, they don't want you doing that. In this case, they don't want you coming in here, flying back out, coming back in, and doing this. What they want you to do, they want you to do this. That's what they want you to do, okay? So that's kind of how that works. Once you're established inbound, they want you here at 2,400 feet for this first, this intermediate segment here on a course of 024, and it's going to be approximately 9.2 nautical miles from this intersection to this intersection of Tebs to get you down, okay? And then from Tebs to Nowak and all the way down the pipe to land right there on runway 2 in Maui, okay? These are the basics of a plan view and how a plan view works, letting you see from the top down what does an approach look like from above. Now we're going to look at it from a profile standpoint. If you're standing on the ground and you're looking out into space and you're seeing, okay, here's what it's going to look like as we come down here, and showing you the vertical elements of it as opposed to just the horizontal elements of it. So now let's take a look at the profile view. To look at the profile view, we're going to scoot this thing down, and here, well, what did I do? I lost my pen. Why did I lose my pen? There we go. Whoop, well, hang on. Goodness. Oh, dropped my pen. Number 7. This is your profile view. So your profile view shows you, here's 3,000 feet, and they don't want you below that, okay? And notice this, 3,000, 3,000, until you get to camps. Once you get to camps, you can descend then from camps down to 2,400 feet, but no lower, until you get to Tebs. Remember Tebs out there? Let me get you out there. Remember Tebs? Okay. Then from here, you see the little Maltese cross here. This is going to be at Tebs. This is going to be our final approach fix. This is going to be where we begin the final portion of our approach. And you can see here is that they're leading you right on down the hypotenuse here. Remember, rise over run. Right on down the hypotenuse, passing these other waypoints to get you to a place to just above the ground to identify the airport and to safely land or go missed. You will also notice on this profile that they also give you the missed approach instructions here as well, okay? So when we look at the profile view, what we're looking at here is we're looking at, here's where we are as we start, we get our altitude and we know kind of what our course is going to be to get here to camps, to this intermediate fix or the initial approach fix where we start coming down, we're now lined up with the runway and we're going downhill to go land. This segment from camps to Tebs, we said was 9.2 miles, right? Right. 9.2 nautical miles. If you think about that, and if you have a ground speed of 120, you're talking about somewhere just about 4.5 minutes on a descent there between camps and TEBs. You can also now start seeing the distances here, but remember, the distance is going to be to the localizer. The localizer is at the far end of the runway. It's not at the approach end. So don't look at the distances here and think that's your threshold, because it's not. It depends on where the localizer is, and it is not uncommon for localizers to be positioned at a far end of a runway, okay? So here you have these, and we know that they want you no lower than 2,400 feet because they have that bar down below it. As you are now on your final approach course of 024, you're at TEBs, you're heading down the pipe. This is that point at which here at TEBs you will pick up and capture your glide slope. The glide slope is that part that we talked about that is going to give you the vertical guidance. Remember, the CDI that moves from left to right is going to capture the horizontal component of it. Am I on my course? Remember, that bar is your course. The glide slope, remember, is that bar or diamond or whatever indicator that moves up and down that tells you where your vertical component of your course is. If the diamond or the bar is up here, that means you're down here. That means you're low, and that's not a place you want to be. So you want to capture that, and when you have them positioned correctly, it kind of looks like a plus sign. So what it looks like is it looks like your localizer is lined up here right in the very middle of your HSI, and your glide slope is right here in the middle of the HSI. So when you have it set and you're flying down at the appropriate angle and speed and your the appropriate horizontal guidance, it's going to look like a plus sign. That's kind of what it looks like, a plus sign. And in fact, it's so funny because you'll see some of the older aviators and you'll kind of know who they are. They'll say, yep, I was glued to the approach. And you'll see them make this little plus sign thing here like that. Well, that's why they do it, is because in some of those older style instruments, that's what it looks like. In the G1000, it looks a little bit different. You have your HSI, which shows you here in the bottom here where your course deviation is, left and right, but then you also have to the left of your altimeter tape, you have another little box that pops up that has a diamond on it to the horizontal line. When that diamond is lined up on that horizontal line, you are set on your glide slope. If it's above you, you're low, go get it. If it's below you, you're high, go get it. Okay, so that's kind of where that is. It looks a little bit different, and I will show you guys what that looks like on a subsequent video when we look at this and show you what the proper glide slope looks like on the G1000. So with this here, now you are on the glide slope. Now it is a matter of energy management. Remember me telling you that so much of flying airplanes is that it's all about the molecule, and it's all about energy management. This is what you're doing now when you're landing this airplane. It's all about energy management, okay? So you're on your right speed, you're on your right course, you're got the right altitude. Everything is looking good as you come down. You're going to pass your various intersections. TEB is where you're going to start that initial approach fix. NOAC is going to be another one along the way. Here you have, again, it just shows you here where your localizer is. And with this one, you'll notice the various distances that you have. These distances along the bottom part are going to be those that are going to take you to the threshold of the runway. Okay, so that's kind of how this works to bring you down and to land you within the first. It actually will take you to the 1,000-foot markers. The localizer will normally take you to the 1,000-foot markers, which ensures the fact that you're going to land within the first 3,000 feet of that runway, okay? Or the first third of the runway, I'll put it that way. All right? So now we look down here below this profile. So now you guys can kind of see how we use this profile to kind of see what are our step downs, what do things look like as we're coming down the pipe here. Then the other thing that we see, and this is going to be that portion here where we reach this portion here, this is where we go missed if we are unable to identify the runway environment. We identify the runway environment with 11 different things, which we haven't talked about yet, but those approach lights are one of them. If we can see the rabbit, if we can see the Mauser leading us in toward that runway, we may not actually be able to see the runway threshold yet at a particular altitude, but if we get to that point and we see the chase lights leading us toward the runway, that allows us to descend an additional 100 feet in an attempt to see the runway. If you can't see it then, you go missed, okay? So that's kind of what that does. Remember that, is that if you see those approach lights there and you see the chase lights leading to the runway, you can descend an additional 100 feet, but no more until you make out that approach end of that runway. Then you can land. So you're always ready to take off again. It's why, again, we always talk about this, why you always have your hand on the throttle anytime you are at or below 500 feet AGL is for this right here. Well, it's for one of the things right there. So that's how that works. Now then, as we look below, we see another box here. This is 8. This tells us our category. What is our category? Well, as you have read from your reading, it has to do with stall speeds times 1.3 of your stall speeds puts you in one of these 5 categories. And in some cases, it can actually be more categories than that. But you'll notice that A is going to be kind of your slower movers. Most of your airplanes are going to be in A and B. Your big airplanes like a 757 is probably going to be in category C. A 767 is probably going to be in category D with these things. And so they have certain requirements that they have based on the speed of your airplane. So that's where these categories come from. And that was in your reading there with your chapters here with the category. Now, ILS runway 2, because remember in the upper right hand corner, we saw that we have the ILS or localizer. So what's the difference? We have ILS or localizer. ¿Por qué? Remember, the ILS gives you not just horizontal guidance, but vertical guidance as well. To fly this approach, let's say that the vertical component isn't working. Let's say it's out of service. It's not working. Can you still fly this approach? Yes. If the localizer portion is working, you can still fly this approach. But now, how is that going to take you down to that point of your decision altitude or decision height for an ILS if you don't have the vertical component? It won't. It can't. You only have DA and DH if you have both components working correctly for vertical guidance. Without the vertical guidance, you have MDA. With vertical guidance, you have a decision altitude or decision height. It means the same thing. One is just an international standard and the one is the US standard. So decision altitude or decision height. That indicates that you're coming down a precision approach, giving you vertical guidance and the horizontal guidance. If that's out, you can now fly this approach with just horizontal guidance, knowing what altitude restrictions that you have to not go below them. Those altitude restrictions are going to be a higher minimum than they would be with the vertical guidance. And here's how we can see that. If we're flying the instrument, the ILS, and we have both horizontal and vertical guidance, if we have both, we can take this airplane down to 254 feet MSL with a half-mile visibility. Half-mile statute visibility. So let's think about this. If we know that here our airport elevation is 54 feet. Let's do some math. Where does this take us here above this runway? 200 feet AGL. And that is where most precision approaches, most of your ILS approaches, will take you down to 200 feet AGL. But we don't call it AGL for civil purposes, for civil aviation or general aviation. We take it to an MSL. And the reason being is because it can be confusing here, this 200 AGL versus MSL. Remember why I told you it is so important to have the correct altimeter setting on your airplanes, especially when you're flying an approach? This is why, my children, is to make sure that you can fly this thing down to this number, 254 MSL, with a properly calibrated altimeter. Without it, you could be lower than you need to be and hit something. That, of course, would just be bad form. Okay, so most ILSs will take you down to 200 feet above ground level to that runway. In this case, that's going to be 254 feet MSL. But Mr. R, what are these other numbers that I see over here that actually show 200, 200 and 1/2? Remember those frequencies that are pretty high over there? And I said that those are military frequencies. Military uses what they call, it's a ground radar system. So they can actually show information AGL because they have a ground radar. From the airplane, they can look and they can shoot the radar here to know how high they are above the ground, not just MSL. And I think some of the commercial aircraft have that as well. And so that's what that second number means. That second number is going to be AGL, not MSL. So remember, this is AGL, this is MSL, all right? And 1/2 statute mile visibility. What happens if they tell you you're starting your approach and they say, oh, by the way, visibility has fallen to a 1/4 mile visibility? Well, you cannot legally land there because you have gone below the minimums required for you to shoot that approach. You got to go somewhere else, okay? So that's kind of what that means. So that is on an ILS. Well, let's say, for instance, that for whatever reason has lost the vertical component for that approach. Without the vertical guidance, without the glide slope, now you can actually fly this approach on a localizer basis in much the same way that you would fly a VOR approach. But notice now how far you can go down. Here, you cannot go below 520 feet MSL and 1/2 statute mile visibility. And here, remember, this is going to be for ground-based, or not ground-based, but for ground radar systems. That's the AGL piece. So what that does is that creates a higher minimum. So if your visibility and they have fog or they have some kind of something going on there where they don't have that visibility, the localizer may not actually get you low enough to land. If the visibility is not that big of a problem, then you should be able to use the localizer to be able to fly down to 520 feet MSL, identify the runway, and land. If you look above this here, you can see why they have these step downs through here. And they don't want you any lower than 980 feet. Why? I'll show you when we look at the visual approach coming in here. And so this is why they have all of these different numbers here, is so that if you're flying the localizer approach, then you know what your step down altitudes are between these various points. So you can kind of see now why you have to have a different rating to fly instruments. There's a lot of stuff going on here, my children. So, but it's very, very cool. So now we can see this. So here's what it is. So they have this broken up here. So they have for the slower movers in categories A and B, these minimums, and for the faster movers, they have separate minimums, but they're the same when it comes here to the localizer approach. Wow, I have just really messed that up there, okay? Now then, so we've talked about the ILS, we've talked about the localizer approach. Now we've got something down here that says circling. That comes in the next chapter, circling approach, because this comes into like the visual maneuvers that you have. Let's say, for instance, that the only approach that might be available to you is going to be the runway 2 approach, a localizer approach to runway 2, but the winds are actually out of the south-southwest, and they're too strong for you to land that way. So remember, we want to land into the wind. We're choosing runway 2 because hopefully most of the winds are kind of coming in here from the north-northeast. But if for whatever reason they're coming in here from the south-southwest, then the tailwind may be too strong for us to land on runway 2. Well, what do? This is where a circling approach comes into play. You fly the approach like you normally would. When you get down to a prescribed altitude, you are then able to fly a big circle out and around the airport, come back in and land on the opposite runway. So instead of landing on runway 2, heading off to the north-northeast, you're going to land on runway 20, coming back to the south-southwest. And so that's what a circling approach allows you to do. In order for you to do that, you have certain altitude minima that you have to meet. You have certain visibility minima that you have to meet, and you can never lose visual sight of that runway. If you lose visual sight of that runway on a circling approach, you got to go missed. And so it's kind of an interesting one to fly because you really kind of have to watch your altitude. You want to stay low because if you go back up into the clouds and you lose sight of that runway, you have to fly the missed approach. If you get too low, you can then potentially violate the principle of DHN. Don't hit nothing, because we don't want to hit nothing. So it's kind of an interesting approach. And you're making one big circle over here to kind of come in here and land this airplane. It has to be stable. It's got to be stabilized, but you are making a visual landing to be sure whenever you're using a circling approach. There are some things that you can do to kind of help you with some of your guidance, but you're hand flying this airplane to land this thing. It's no challenge at all. No challenge. It's not as big a deal in smaller airplanes, but when you're flying the big boys and you have to do this, I can see how that would be a bit of a challenge to fly that type of an airplane on a circling minimum. My guess is that you have certain carriers who say, we don't fly circling approaches. We just don't do it. It's there. It's legal. They can, but should they? You know, if I'm seeing a 777 kind of coming around here, 500 feet off the deck, making maneuvers like that, I'm probably going to watch that. So I'm just saying. So that is what a circling approach is. A circling approach allows us to use an approach to a particular minima, to a particular point, and then fly visually around to come back in and land on a different runway than what the actual approach plate indicates. It's perfectly legal. You can't just do it spontaneously. The tower needs to know what you're doing, but you can do it. But note the minima. In category A, which is going to kind of be us, the little bug smashers, you can go down to 520 feet. If you're flying at 120 knots up here, then you're going to have to, you won't be able to get as low. You got to stay higher. And if you're flying some of these bigger bad boys over here, you got to be even higher yet. So again, here's your 767 over here, here's your 757, and I don't know what the approach speeds are for a 777, but I can't imagine it wouldn't be between these guys here. My guess is here, this is probably going to be your F-18s, your F-22s, things like that, your kind of your real fast moving airplanes. You can't get as low to the ground because, again, you're moving at some pretty good speeds here as you do this. And we'll talk about the circling approaches here as we get to this here in this next chapter. So just know that kind of that's what it is. Now, last box. The last box, well, I say the last two boxes. Here we have a small version of what the runway, of what the airport looks like. Top-down view of what the airport looks like. And you can see runway 2 here. You can see the Mauser here for runway 2. You can see the opposite end here. You can see that you also have runway 5, runway 23 over here. This kind of tells you where you're going to be landing. It kind of gives you that lineup that you have. Reiterates the elevation and the touchdown zone information. Okay, so it gives you some lighting information here as well with this. And so, yeah, that kind of gives you sort of a top-down view of what that airport looks like. They have a separate airport diagram, which we're going to look at here in this next part that we look at. But this gives you just a quick kind of a synopsis view of the airport as you're looking at the approach plate. Then below that, you also have this. So remember that we talk about some of the timing elements. Final approach fix to the missed approach point, 7.2 miles. Then below this, it gives you a speed here in knots, and it gives you a timing in minutes and seconds. So why is that there? Well, if we're flying this missed approach on a localizer basis, we want to know timing-wise, when should I be at a particular point, and how will I know? Here's where the timing comes into play. First of all, this speed in knots is ground speed. Ground speed. Right here, this is going to be a calculated ground speed. It is the only way that you can calculate time, speed, and distance is with a ground speed. The category speed here is an indicated airspeed. So this is going to be airspeed. This is ground speed, okay? Then when you look at this, if you do the math, and you say, okay, it's 7.2 nautical miles from the final approach fix to the missed approach point. If I am traveling at a ground speed of 60 knots, then it should take me 7.2 minutes to get there, right? Well, 7.2 minutes, first of all, 0.1 minute is 6 seconds, right? Because you have, you think about your clock and you think about what that's going to be. So a tenth of a minute is going to be 6 seconds, okay? 0.2 is going to be 6 times 2, so 12. 7 minutes and 12 seconds with a ground speed of 60 knots, okay? You can practice this on your E6Bs. At 90, at a ground speed of 90, it will be 4 minutes and 48 seconds for you to reach your missed approach point, your MAP, okay? So with that, that tells you from a timing standpoint how long that is. You guys have read the regulations. Why is it that you have to have a working timer with either a digital display or a sweep second hand working and available in your airplane for it to be instrument certified? It's for this. You have to be able to time these descents if you need to. You have to time turns when you need to. You have to know that if you're flying a hold, so let's say, for instance, that we see something here that talks about a 1 minute holding pattern, we need to be able to time that, don't we? So that's why it's important to have the ability to time something in the airplane. So that's what this part means. Now, your book will show you all of these things that you and I have just covered here with these. In the next part, we're going to be looking at the airport diagram, and we're going to be looking at how an ILS or a localizer approach compares to a VOR approach and an RNAV or GPS approach. There's a special chapter for GPS approaches. There's a special chapter for VOR approaches. But I want to introduce it to you before you see them so that those chapters hopefully make a little more sense. Whew. Anyway, guys, there you go. Remember, I told you how this was going to be. But it's just getting to the real fun stuff. Anyway, there you go, guys. And I will talk to you here on this next video. See ya.